Okay, so number 5, it gives you a picture here. Measure of angle 1 is 3x plus 5. Measure of angle 2, it gives you an expression as well, and it asks you to find x. In order to know how to set this up, you do have to look at the picture. So measure of angle 1 is 3x plus 15, and then measure of angle 2 is 6x plus 3. And we look at that, we notice that 1 and 2 are vertical angles, so therefore those expressions must be equal. So you just set these equal, and then you can solve for x. And x equals 4. Did any of you get that? Cool. Awesome. Number 6, it says, and it gives us a picture as well, if measure of angle ABC is 34, find CBD. First of all, you need to figure out what they're talking about. Angle ABC is right here, and it's saying that's 34 degrees. We can see that CBD is adjacent and complementary to that angle. We know it's complementary because of this little square. So therefore, to find this angle, we would have to do 90 minus 34 to get 56 degrees. And that's our answer. So as I'm going through these, consider any variation of this. What if it was a linear pair? Then they would add to 180. So you might have to do 180 minus the number or something like that. Then here we are jumping into the proofs. So like I said, on your test you will have a bunch of multiple choice, and then you'll also have some of the proof questions. And they'll be set up just like you saw on the homework with the drag and drop. So you won't actually have to come up with anything out of like thin air. Everything will be in an answer bank where you drag it into the place it's supposed to be. Before you even look at the problem, you should be plugging in the given and the proof statement. So our given is angle 1 is congruent to angle 3. The reason that is given. And the proof statement, angle 1 is congruent to angle 2. And then from there, you've already narrowed it down quite a bit. Okay, so here it says angle 3 is congruent to angle 2. Looking up here, they are vertical angles. So yeah, 3 is equal to 2 because of vertical angle theorem. And then for the last one, we only have one answer choice left. Just if you're going to plug it in, make sure it makes sense at least. Transitive property of congruence. If 1 is equal to 3 and 3 is equal to 2, then 1 and 2 must be equal, and that's what they put here. Okay, next. Move up to this corner of the page. This is one that you didn't see in the homework. It says complete the following proof. It has your given and your proof. As far as the given, just trying to shortcut this here, put it on the lines. AB is congruent to DE. B is the midpoint of AC. And E is the midpoint of DF. So this practice test, I will be checking it at the end of class. As long as you write everything that I've written, you get full credit. And then you can take it home to study for tonight as well. So I just put the given statement right there. It already says given. The proof statement will go on my last line. So BC is congruent to EF. And now I just have to fill in the rest. Just looking at what it says in regards to the picture, it says AB is congruent to DE, so those are the same length. It also says B is the midpoint of AC, so that means both these sides are going to be the same measure, and E is a midpoint here, so both of these sides are going to be the same measure, so essentially everything is equal. Right here it says AB is equal to DE. That's just saying if they're congruent, then they are the same length. That's definition of congruence. And there is no answer bank on this question, but if you have it on the test, there will be an answer bank. Definition of midpoint, what they're getting at there is if B is the midpoint of AC, then AB equals BC. And if E is the midpoint of this segment, then DE equals EF. Then for D, it has BC equals DE. You could look at this for a while and figure out that they're substituting, since AB equals DE, they just plug that in for AB here and AB, or they plugged it in here. Sometimes it's hard to tell where they're plugging it in. But they're using substitution. And if you look up at the picture at BC and DE, they're on completely different parts of the picture, so it has to be substitution. Then BC equals EF. Again, they're on different parts of the picture. They're using substitution. And then last but not least, they're changing this into equal into congruent, so definition of congruent segments. And moving down. Okay. Next one, this one you saw on your homework. If you were just guessing on your homework or you didn't really understand it, now's the time where I'm going over it like step by step. Of course, first thing, plug in your given, plug in your proof statement. So just quickly jot those in here. AB is congruent to CD, and BC is congruent to DE. Reason given, proof statement, and then I can cross these out here too. Okay, next it says definition of congruent segment. So since these are congruent, they're also equal in length. So we're just going to write down AB equals CD and BC equals DE. Next, for this one, you may recognize this format is usually segment addition postulate, and that is correct. AB plus BC equals the whole thing, and DE plus CD equals the whole thing. So segment addition postulate. And we can abbreviate there. Then it says CD plus DE, so this over here equals this over here. Well, they must be using substitution. Now we could sit there and try to figure out what they substituted, but it ain't worth our time. Then EC equals AC, looking over here, EC equals AC. Again, substitution. And then last but not least, turn it into congruent definition of congruent segments. Moving on. Yeah, there's back. I tried to, so you know how like our copy budget, I tried to shrink it down on 2 pages. And it fits, but there's no way you'd be able to like write in the little spaces. So I splurged, it's front and back. Okay. So again, you've seen these before. I'm going to quickly go through them because I know y'all getting bored already. So plugging in the given doesn't really fit in that space. So I'm going to do a circle around this and just put an arrow there. I'm not going to do that for all of them, but for that one, there's no other way to do it. I'm going to look at what that given says. It says C is the midpoint of AE, so that means this is going to equal this. C is the midpoint of BD, so that's going to equal there. And it also says that AE, so this segment, is the same length as this one. Okay. Now for the second statement, AC equals CE. The reason why those are equal is definition of midpoint.
Wait, is midpoint even on the answer?
What's that? I just crossed it out. What do you, yeah, it is. This will cross out too. Okay. Then we have AE equals BD. Where did that come from? Well, it said that they were congruent, and now it's saying they're equal. So that's definition of congruent segments. Then segment addition postulate. That would be looking down here. It's this one right here. And I'm just going to draw an arrow for that one because it's too big. Would it be helpful to you if I re-enabled last week's homework so you could practice these again? I don't know. Would anybody want to study that way? Do you understand? Like, these were on the homework last week where you drag and drop. I can enable them so you can get on them if you want to practice more. It's up to you guys. Then for this one, it is AC. So, whoa, there's a fly on my arm. That's so gross. Go away. Anyways, this is substitution. And then it's substitution again. And from here, it's saying simplify. So they have 2 ACs and 2 CDs. So they simplified it as 2 AC equals 2 CD. Simplify. Then dividing both sides by 2, that's where they got division property. And then you would get AC equals CD. We're getting close to the proof statement. And then they just change that into a congruent symbol. So that's definition of congruence. Okay, I'm moving down. Are you keeping up with me? Should I speed it up? Okay. Next. Angle 1 and 2 form a linear pair. 1 and 3. I'm going to just draw an arrow for this one because it's not going to fit in that spot. And then reason is given. I'm also going to plug in the proof statement. Angle 2 and angle 3 supplementary. Then it says 1 and 2 are supplementary. I was told that 1 and 2 are a linear pair, and by definition, if they're a linear pair, they are supplementary. So linear pair postulate. Then if they are supplementary, they must add to 180 degrees. So measure of angle 1 plus measure of angle 2 equals 180. Definition of supplementary angles. Next one, angle 1 and angle 3 are equal. We were told that they are congruent. Now it's saying that they are equal, so that would be definition of congruence. Then 3 plus 2 equals 180. Well, if 1 equals 3, they could take this measure of angle 3 and plug it into this equation for measure of angle 1. And that's what they're doing, so that is substitution. And last but not least, 2 and 3 are supplementary. That would be definition of supplementary angles. Okay, next, moving down here. Again, another one you've seen before, plugging given. LK is congruent to NM right here. Then MJ is congruent to KJ, just based on the given. Then it says definition of congruent segment, so they must want to say that LK is equal in length to NM, and KJ is equal in length to MJ. The next step isn't really all that obvious until I point it out. So you can add the same thing to both sides, and you still have an equal equation. So since these two are equal, you could add each one of these to each side of this equation, and it would still be equal. So they're adding KJ to this side and MJ to this side. So that would be addition property of equality. And then segment addition postulate. I'm just looking for the right format there, and that's this, where one side of the segment plus the other side equals the entire segment. LJ equals NJ, that's substitution. And last but not least, definition of congruent segments. And thank you, next. Moving up to the top. Okay, plugging everything in, the given, the proof, PL equals AN. Okay, PL plus LA equals PA, that's segment addition postulate. And then LA plus AN equals LN, that is segment addition postulate as well. Then for this one, since PA equals LN and both of this equals PA and LN, they set these two equal, so that is substitution. You could also say maybe transitive, but transitive isn't in the answer bank, so they're looking for substitution. And then last but not least, PL equals AN. So to get that, they're subtracting LA from both sides, so that is subtraction property. And continuing, you guys keeping up? Okay, awesome. Next, given angle 1 and 3 are complementary, 2 and 3 are complementary, prove that 1 is equal to 2. Okay, first they start out with 1 plus 3 is 90 and 2 plus 3 is 90. That would be definition of complementary angles. Then, since both of these are equal to 90, they set these expressions equal to each other, so substitution. Or transitive, depending on what's in the answer bank. Reflexive property, looking at my answer choices, it would have to be this one. Measure of angle 3 equals measure of angle 3. Then what they do is they subtract the measure of angle 3 from both sides of this equation to just get measure of angle 1 equals measure of angle 2. So that is subtraction property. And then angle 1 is congruent to angle 2. That's definition of congruence. Okay, last but not least, of course, fill in all the things you know. Okay, so it says BD bisects ABC, so that means both sides are the same measure. And angle 1 does equal angle 2. The reason why is definition of angle bisector. Then angle 1 is congruent to angle 3. Yes, they are, because they are vertical angles. So vertical angle theorem. And last but not least, 2 is then equal to 3. If 1's equal to 2 and 1's equal to 3, then 2 and 3 are then equal. And that is transitive property. Okay, that's it. Yeah, sure.